Hello everyone, this is Miguel Greenberg, and today we are once again working with React and Flask. What I'm going to do in this video is show you how to do a deployment of a combined Flask and React application using Docker. So the idea here is that what I showed you in the past, the deployment methods that I showed you in a previous video are a good foundation, but they require a lot of manual steps. So if you do this often, then it becomes tiring to have to repeat all these steps. And also it's not a good idea to deploy by hand, right? We don't want to do that. We want to automate as much as possible this process. So what I'm going to do today is take the instructions that I shared in that previous video, and I'm going to automate everything as Docker containers. So then everything is going to be scripted and basically one command and you get a deployment up and running. So if you recall in that video where I shared the two deployment methods, one was based on GUnicorn alone, and GUnicorn served the React files and also it connected with the Flask application. And then there was a second, more complex deployment that used Nginx to serve the React application, and also it worked as a reverse proxy that sent requests into the API, which run on GUnicorn again. So those are the two methods that I showed you last time, and now I'm going to show you a version of those two using Docker containers. So I'm going to start from the easiest task, which is to create a Docker container for the API, just for the API. So I have here a Docker file for the API, which you can see that it's very short. It's based on the official Python 3.9 Docker container image. I like to set up a individual specific directory where the application goes. So this is /app in this container image. So basically the installation involves copying all the files into this directory. So requirements.txt, api.py, and the .flaskenv. These are the only files for the API project. So these are copied into the current directory. In Docker, if you set a work directory, then all the relative directories that you use after are relative to that. So this effectively goes into /app. So once I have all the files there, I install the requirements. This is optional. The flaskenv file that I used was created mainly for development, right? Because it basically it's used by the Flask command. So it had a flaskenv equals development variable in it. So, you know, just to keep things neat, I decided to override that in the environment and set it to production, because this is what this is. It doesn't really matter in reality because we're not going to use the Flask command for this deployment. So you know, if you don't do it, it doesn't break anything. But just, you know, to keep things neat and you know, to make them be correct as much as possible, I decided to set that variable. And then that's it, right? We tell Docker that port 5000 is going to be the port where this application is going to listen, and then we have a command, a start command, which is GUnicorn -b :5000, and then the API :app specification, exactly the same thing that we did when we deployed this by hand. So this is all that's required to get this container going. So what you need to do now is build a container image. So we use docker build. We have to specify the name of the Docker file. So Docker will look for a Docker file named just Docker file. since I'm going to have a bunch of them here, they all have different names, so I have to specify the name. And then the container image that we would like to use, we can give it the name React Flask App API, and then the directory, the top level directory for the build, which is this directory. So there we go. We can build this, and this is going to take a little bit of time, and that's it. So what we do now is just to test. We can do Docker run. Let's see. I'm going to use one of my previous commands here. So we are going to map port 5000 from the container to port 5000 in the host, and then here we have the name of the container image. So this is going to start an API container. This runs the gunicorn command, and port 5000 is now port 5000 in my machine. So I can test this by making an API request. Remember that this is the API, so it was a /API/time request. Okay, so we got a 404 error. This is, I think, it has to be the Chrome looking for the icon. Yeah, there you go. So this is looking for the icon. That's a 404, but the API request is working, so everything is good here. So this is the only thing we can do so far. We don't have the React part yet. So let's stop this, and now let's look at a second Docker file for the React files. This is going to be a little bit more involved, because as you recall, we have to build the React project. The React project, you can deploy it for development, but then when you're ready to deploy for production, you have to build an optimized set of files that basically the React build generates. So we have to do all of that. So what we do here is we start from the Node.js image. This is an image that has Node, NPM, and Yarn. So all of that is pre-installed on this image. So we don't have to worry about installing any of that. This as-built step, you may not be familiar with this. I'm going to explain what that means in a moment. It's a relatively new feature of Docker that is super useful. So hold on to that. I'll tell you in a minute what that is. So like in the previous time, I create a directory for my application. This environment, it sets the path. I'm not sure I don't think this is necessary in this particular case, but it's good practice to have the bin directory from your installation of Node.js, all the dependencies that you have, to have it in the path so that you can call commands without having to use the full path. So that's what this does. And then like in the previous Docker file, and this one we have to copy all the project files, this time are the React project files, to the container on this app directory. So we copy package.json, which has the list of dependencies, yarn.lock, which has the actual versions of all the dependencies and all the second-hand and third-hand dependencies. So all of that goes into the application. And then we have the source directory, which has the source code for the React app, and the public directory, which has the static files that the application uses. So once we have all of that in the container image, we can call yarn install to get all the dependencies installed, and then yarn build to generate those optimized files for the React application. So this is going to run for a while, and now we're going to have the React application built on the /app/build directory. This is exactly as we did manually in the past, right? So no difference there. So here where the interesting part comes. If now I add Nginx to this image and configure it and that's it, and complete the deployment, I'm going to end up with a Docker image that has Node.js and Yarn in addition to the files that I need and Nginx, right? But the thing is, once you build the project, you don't really need to have Node.js installed. And Node.js is not used. The only thing that we need is the bunch of static files that are in that build directory. So what we would like is to keep the Docker image, the container image, as lightweight as possible. So we would like to remove Node.js from the image. And really a very good way to do that is to use this somewhat new feature of Docker called multi-stage builds, which is exactly what this really does. And the idea is that you run your build, and then when you're done and you generated a bunch of files that you need, you basically erase everything and start from a new container image to build the final image that you want. And the only thing that you get from the first, let's call it a temporary build, is that you can copy files from that build. But nothing that you installed is preserved. Everything is thrown away. So what we're doing here is now we are starting over from scratch using the Nginx official image, which is actually very small. And what we do is we copy from build step, which is the previous build, the app.build or app/build directory. And we put it in the place where the Nginx container image wants static files to be, which is this user share Nginx HTML. This is how the Nginx container works. So we put all the files there, and basically that's it, and that's all we need. So now we have a container image that doesn't have any overhead. It doesn't have Node or Yarn or any other stuff that we don't need. So the last thing that we need is to configure Nginx. So if this was a standard project with just static files, this line that copies the Nginx configuration will not be needed, because the default configuration that comes with the Nginx container image is sufficient for that. The problem is that we need an additional function for Nginx. We don't only need Nginx to serve the static files, but we also need to proxy the API. So for that reason, we have to replace the default Nginx configuration with our own. And we already know how to do this. I explained how to configure Nginx in the previous deployment video. So I'm going to show you now the configuration, which is basically based on what we did in the past. So we have a root directory, which is the place where this Nginx container wants the static files. And then we have a default index page. And we have the location for the root URL, which is the block that configures the React application, so static files. We use the try files, and we configure the caching exactly as we did before. We have a secondary location for /static, which is the subdirectory of the build directory of the React project that needs to be cached long time or long term. So for this one, we set up 1 year of caching, which is what we did in the past. And then finally, we add a /API location block that proxies to the port 5000, which is the port where we are running the API. And here we are using API as hostname. In the past, we used localhost because running directly on the host machine. But now for Docker, we're going to use a networking setup where the container running the React application will see the other container running the API with a host name. It's going to be API. So that's what we use here. So this basically builds the React container. One thing that I'm going to mention, you saw on the API Docker file that at the bottom I had a CMD statement which provided the start command for the container. For this container, we don't have to do that because we're starting from the Nginx container image, which comes with a command already, and that command is perfectly fine for our needs. Basically runs Nginx with the configuration file that's provided. So we don't have to provide a start command on this one. So that's it basically. So we can try to build this one. So this one is dockerfile.client. I'm going to call the image React Flask app client, and this is going to build. This is not going to be that quick for you the first time. There's a bunch of things that are cached here because I ran this before. Just so you know, it will take a minute or a minute and a half probably, just so you know. But anyway, now we have the two container images, one for the API and one for the React client. I'm not going to run this one. If I try to run this container with Docker run as I did before, Nginx is going to fail. And the reason it's going to fail is that when it tries to parse that line, the proxy pass line that sends API requests to http://API:5000, it's going to error there because it's not going to recognize the API hostname. When you run this container on its own, the API hostname is undefined, so that's going to be an error. So what we need to do now is we need to orchestrate the two containers to run together as part of a private network. And the best way to do that, the easiest way to do that, is to use Docker Compose. So the final part of this solution is to create a Docker Compose.yaml configuration file that defines how these two containers are going to run together. So here we have a services section with two subkeys, API and client. These are the two containers. Both have a build section that define how to build a container. This is really optional. I mean, you can continue to build the containers as I did before with the Docker build command. But if you put the build information here, then you can say Docker Compose build, or you don't even need to say it, because Docker Compose will build the images when it detects that they are out of date on its own. So it's more convenient to have the context is the top level directory, which is the current directory, and then the Docker file, and then the image key provides the name of the image, which is optional. But I like to provide the name so that then when I look at images, I know what each image is. So what else do we have here? For the client uses the Nginx container image, which runs on port 80. So we are going to map port 80 from the container into port 3000 on my machine, just so that we can then connect from the browser here. We don't need to have any ports on the API container because that is now a private container. We don't need to access that container from the outside. The only client for the API container is going to be Nginx running on the client container. We're not going to send requests directly into the API container from the outside. So it can be a private container. And really this is it. So Docker Compose will start these two containers, as part of a private network, and then it's going to configure the so on the API container, it's going to configure a client host name, so the name of the other container, and then in the client container is going to configure an API host name, which is going to map to this container. And this is how these two containers can talk to each other. And really that's it. So what we need to do now is Docker Compose up, and this builds any container images that are out of date, and then it starts the two containers as part of a single network. Now we're starting to see some logging from both containers, so you can see the combined logging output now from both, and let's cross our fingers. This is on port 3000, and here we go. We have our beloved test application, the same application that I've used in the previous parts, all running. You can see this is the result of the API call. So each time I refresh, this is updating. So the API call is working, and this is the little example of routing, client-side routing that I built. Everything is working great. So this is the complex solution. So this is the solution that involves Nginx in front of GUnicorn. So what I'm left to show you is the single container solution. A solution that is only based on GUnicorn serving everything in a single instance, which sometimes is more convenient. And this is for the deployment. This is more robust. Having the two containers set up is more robust. This is definitely what I would use. But sometimes, for convenience, you want just a one container thing that can do everything. It serves the client files to the browser, and also respond to API requests. So stop this with Control-C and look at one more Docker file, which is the combination of both client and server in the same container. So this is based on the work that I did for the previous two container Docker files. So this is combines bits from both. So you're going to find that the first stage build this is identical to what I did for the client container before. So this builds the client side, the React application, and it works exactly the same. So no change here. So then when I'm ready to do my final container image, now I use Python 3.9, and with Python 3.9 I set up my app application directory and copy the files from the app/build to .build. So this effectively will be /app/build. So this is where the files are going to be. And if you recall from the GUnicorn solution that I showed you by hand, this was because we were serving the static files from the build directory that was left there when we run yarn build. So I'm trying to preserve that same file structure where there's an API and a build directory. So this is the build directory for the client. And then next I create the API directory for the server, the Flask server. And here, as I did before in the other container, I copy all the container files, and then I run pip install to get all the requirements. I adjust the Flask env to be production just in case, and then we expose port 3000. We're going to run this on port 3000, and before I give you the CMD command, the command that starts everything, I change one more time the working directory to the API directory, so that Docker will start with the API directory as the current directory. So once that is set, I can run gunicorn, and this is going to be in the current directory, so no problem there. And then the api.py file has, this is from the previous time that we did this, it has the static folder configured as /build. So this is going to go from the API directory up to /app and then down into build to get the static files. And that's it. So this should be all that it takes to get the single container solution up and running. So let's so this is going to be combo, and this one, let's call it React Flask app. So let's build a container image for the single container solution. Apparently I don't have this one cached, so it's going to take a little bit of time. So this is a more realistic build time that you will see when you run this the first time. Once you do it once, then if you need to redo it often, you know, a lot of things are cached and it doesn't take that long. But the very first time it does take a bit of time to get everything installed, especially the JavaScript side. So we will wait for this to finish. Okay, there we go. So it took about a minute and a half to get this this image completed. And what we can do now is we can just run this. So this one was on port 3000. We can put it on 3000 in the host as well, and that was the name of the image. So let's give this a try, and let's go to localhost 3000, and there we go. We have the same application now deployed as a single container solution for convenience. So now you have both options. You can pick the one that works best for you. So anyway, hope this was useful. If you have any other ideas for topics that I can show you by extending this this little project, by all means let me know. But anyway, I hope you have fun with this and that you can adapt it to your own projects. Thank you so much. Bye bye.